Hello everyone, this is Hong. In this video, I'm going to show you the hardware of Polaris GEM E2 vehicle. If you also have this PDF, you can open it and go through it with me. We are going to talk about the hardware, the first part. As you can see, this vehicle is equipped with several sensors. For example, camera sensor, radar sensor, lidar sensor, and there's also a GPS module inside the vehicle. These two antennas are for the GPS module. You can control the vehicle, for example, the steering, braking, acceleration. And you can also control the gear selection, for example, forward, reverse, or neutral. There's a display screen to show you the power distribution among the sensors. In order to control the vehicle, you need to know the relative distance and orientation with respect to the base link of the vehicle. Here, assume like the base link of the vehicle is located at the GPS module. So there's, this is the distance and orientations uh, for the lidar sensor with respect to the GPS module, and this is the radar, uh, the orientation and the distance with respect to this GPS module. There's also a camera sensor in front of the vehicle here. Remember in ROS, we use meters instead of millimeters, so you need to convert the millimeter to meters in ROS. Sometimes we also refer this GPS plus IMU module as the GNSS module. So here is the picture for the hardware connections. We have a PDU, stands for Power Distribution Unit, and we have a front monitor connect to the station or computer that we are going to use. We have a PAC-mod module, a USB to CAN converter. PAC-mod stands for Platform Actuation and Control Module. This is the module that received the ROS messages and decoded and sent the CAN bus messages to control the vehicle. The white one is the GPS module, the black one is the MU module. They are bundled and used together. So also we refer this as a GNSS module. This is the front camera module, and we have the lidar module mounted on the roof of the vehicle. The version we use is VLP-16, and we have a wireless keyboards and a joystick controller. So you may notice that uh, the color of the cable is different. So for example, for the purple ones, they are Ethernet cable. For the green ones, they are CAN bus cable. For the red ones, it's a HDMI cable. So in order to use the vehicle, you need to power it on, right? So on the left side, the picture show you like several relays and fuse. You will never try to modify or touch it. But whenever you want to use the vehicle, you want to turn on it. So this is the master power switch. It is located at the driver's seat. Your TA will show you where is it. This is the automated research development platform. So this is front picture and this is the back picture. So remember we have mounted a front radar in the front of the vehicle. So it's a 3-inch by 1.5-inch 8020. This is the station, in other words, the computer that we are going to use to control the vehicle. It has 6 Ethernet ports, 4 3.0 ports, 4 2.0 ports, and it is installed with a GTS 1050 GPU with 16 GB RAM. It is installed with Ubuntu Linux 16.04 and ROS Kinetic. This is the connection for the sensors to the computer. So from the left to the right, the green cable is the lidar cable. The yellow cable is the camera cable. I'm sorry, the yellow cable is the GNSS cable, and the black cable is the camera cable. This black cable in the center is used to boot the computer when you switch on the vehicle. These two USB cable, one is for the pack module, one is for the joystick controller. So this is the pack module. This module is designed and built from Autonomous Staff. It's a company which provides service to our university. So we have installed ROS on this computer. The ROS system will send ROS messages to this PACMod module, and this module will decode the ROS messages and send the corresponding CAN bus messages to the vehicle in order to control this vehicle. So for example, you can control the steering, brake, acceleration, shifting, and turn signals. We have some safety concerns, right? So whenever you want to take control of the vehicle and you feel it's unsafe to let this computer to control the vehicle, you just use this brake to disconnect the connection between the computer and the pack mod, and then you can manually take control of the vehicle. So this is very important. Uh, we can also use joystick controller to control the vehicle. The joystick controller we'll use is a Logitech F310. So you just make sure whenever you want to use this joystick controller, make the LED off and set it to X mode. This is the map for the buttons for this joystick controller. So if you are familiar with ROS, this is the launch file to launch the joystick controller program. By the way, you can also double-click this icon at the desktop to launch this program. So in this launch file, the vehicle we are going to use is Polaris GEM, and we are going to use drive-by-wire to control this vehicle. In order to let this joystick controller to control the vehicle, you use these two buttons. You need to press these two buttons simultaneously at the same time. And after that, you want the vehicle to move forward. You use this green button, forward, and use this gas button and brake button to move the vehicle or to brake the vehicle. The joystick on the left can help you to control the steering wheel, turn left and turn right. So if you want to move the vehicle backward or reverse, you use this red button and use this gas button and brake button to control the vehicle. Next, this is the camera we are going to use. So this camera is mounted in the front of the vehicle. It can provide 2064 by 1544 resolution. So at this resolution, we can have 37.5 frame rate. So if you have a smaller images, you may have a higher frame rate. The format we're going to use is RGB color pixel formats. So this is defined in the launch file of the ROS program. This is the dimension of the camera. This is the port, the power port of the camera. So we're going to introduce the LiDAR sensor. The LiDAR sensor is mounted on the roof of the vehicle. The dimension of the LiDAR. This LiDAR is a 3D LiDAR. In other words, it can sense the 3D sorry. So it has 16 layers or 16 rings. So it has from 0 to 15. So for zero layer, it has a pitch angle of negative 15 degree. And for the 15th layer, it has a 15 degree uh, pitch angle. This LiDAR can measure from 100 meters to 120 meters at the maximum. And angular resolution is 2.0 degree vertically. And field of view vertically is from plus 15 degree to negative 15 degree. The field of view horizontal is 360 degree. So for this LiDAR, it can provide 300,000 points per second. This is huge. So we need to process this point cloud in order to do the object detection, object classification. This sensor is use 100 Mbps Ethernet cable to connect to the station. It uses UDP packs. Next is the radar sensor. So the radar sensor uses a CAN bus connection to the station. So the difference between the radar sensor and LiDAR sensor is that the LiDAR sensor can give us like the distance of the object with respect to the vehicle, whereas the radar sensor can not only provide the distance of the object, but also the velocity of the object. And typically, the radar sensor is measured in the polar coordinates, whereas the LiDAR sensor can be used in the Cartesian coordinates. Next is the GPS and IMU module. So sometimes you may think like a GPS module plus IMU module as a GNSS module. So this GPS module can not only receive GPS signal but also receive the BeiDou signal as well as the GLONASS signal. So and the update rate is up to 20 Hertz. So this is the connection for this GPS module. Uh, the antenna for this GPS, the power, and the yellow cable to the station, and the GPS sync module, and one cable to connect to the IMU module. So the reason we want to combine this GPS module with the IMU module is that it's a typical way to do that because for the GPS module, the update frame rates is usually like very low, probably from 10 hertz to 20 hertz, whereas the IMU module the frame update rates can be up to 100 hertz, like 200 hertz or also 1000 hertz. So we want to leverage the advantage of both sensors to give us a precise localization estimation. So this is the port connection for this GPS module. So this is the GPS sync module. So one cable, this is the Valendine like sync module. This is the span IMU module. So the frame rate, not frame rate, sorry, the update rates for this IMU module is 125 Hertz. This is IMU, so it marks with the like orientation on the top of this module. So remember the forward direction for this module is Y plus, and the to the left to the right is X positive, and the up is Z positive. So you need to convert this in the ROS system. Remember, in the ROS system, the forward is always positive X, and to the left is always positive Z, and upwards is the same. To the left is always positive Y, and the up is always the same, positive Z. So pay attention to this when you want to use this sensor. And this is the GPS antenna to receive the GPS signal for the module. Yeah, this is done. This is the hardware that we are going to use for this Polaris GEM E2 vehicle.